Hi class, we are team named Segmentation Fault. For milestone 1 to 3, we are using a common setup which has Jenkins deployed on DigitalOcean Droplet as a build server. For milestone 1, we have used Node.js project as a Jenkins setup. Consists of 3 job items, dev, release, and master. These jobs are configured with Git repository as a source code, and a build would be triggered when a change is pushed to GitHub. For a purpose of triggering the build, GitHub repo is configured with a Jenkins webhook. The jobs are triggered on a Git commit and the source code is built via a build script specified in Jenkins job configuration. On failure or success of the build, the Jenkins is configured to trigger an email with the status as a post-build task. Here we show the history consists of all the builds triggered so far. For milestone 2, we have used an open source Maven project. Our test setup consists of JUnit library and Rundoop plugin installed on Eclipse. We have used this Rundoop plugin to generate tests for Maven project and for the purpose of improving the test coverage. As a pre-commit step, we first check for the presence of any AWS or DigitalOcean security tokens and fail the build if found one. Here Jenkins is set up with 2 jobs, one with default and the other with the Rundoop test coverage. These jobs are triggered as a result of Git commits similar to milestone 1. We have implemented a custom analysis test approach which is executed as a pre-build step and checks for the number of import statements in each source code file. For the purpose of measuring the test coverage, we are using the Covertura plugin with Jenkins. For the static analysis on the source code, we are using the find bug and check style tool. Covertura test coverage report shows the coverage for the existing tests in the source code. Here the static analysis tool results for the find bugs and check styles are shown. To implement the ability for minimum testing and analysis criteria, we have used Covertura find bugs plugin utility to mark the code with unhealthy or stable build if the coverage is below a certain threshold. If the build is marked as unstable or unhealthy, the Jenkins triggers the email for the failure of the build. Now we run the Rundoop test. Here we can clearly see the coverage report has increased. We have applied the same custom and analysis to this Jenkins job as well.
Milestone M3. After build, test and analysis stage, M3 focuses on deployment of software into production and dev environments. For the purpose of M3, we are using Node.js project as our source code and Docker containers as deployment servers. We have 2 Jenkins jobs, M3 prod and M3 dev, each configured with GitHub repository as source code. The jobs run sudo npm install and sudo npm test as build steps. As a post-build script, these jobs instantiate dev and prod Docker containers to deploy the app. Here we showed that the prod job is built successfully and deploys the app to 3 Docker containers. The proxy server and the global Redis server are running on the droplet running Jenkins and deployment containers. The proxy server load balances the request to all production servers. Now we turn on the feature flags on all particular servers. When the request is made for the particular feature, the proxy server load balances the request only to the servers on which the feature is turned on. Here are the Redis server entries for the queues for each feature. Now when we turn off the feature on a particular server, the entry for that server is removed from the Redis queue for that feature and proxy server no longer forwards the request to the server. The ability to monitor the deployed application is provided by running a cron job every minute. This job monitors the CPU and memory usage of a Docker container and notifies the user via email if the threshold is crossed. Now when the canary and dev servers are deployed, the proxy server routes a percentage of traffic to these newly staged deployment servers. The cron job monitors the dev servers and also stops routing traffic if an alert is raised. Finally, let us have a look at a special milestone, database redundancy. The purpose of this milestone is mirroring the database to ensure high availability. This is an architecture diagram shown. It will be further explained in the demonstration ahead. So here we have our 2 sides, client side and server side. On the client side, we can see that only one container is running, the Redis ambassador container, which is spawned up using the docker compose.yml file, as you can see. And now let's create a Redis CLI. So here we are pinging the Redis database, which is running on another container on another droplet. So for our ping, we get our pong, and these are the particular keys which are present in the database. So let us set another key, and we get that key to make sure. Okay, and now let us go to our master. Over here on our server side, we have the following containers: the Redis ambassador, the master, and the slave. uh, let's enter the master container. So over here we run the Redis CLI, and in the Redis CLI we check whether those keys are still present. Bring down the master, so we exit from the master and then we kill the master. Okay, so our master is down. This is our script which is run by the cron job every minute, and what this script basically does is it checks whether the master is running or not. If the master is down, it makes the slave the new active Redis database or the new master. So as you can see, the failover script is run every minute in the cron job. As you can see, a new Redis ambassador is now created for the new slave, which is the active database. Let us go to our client and now check whether we can still reach our database or not. So when we do a ping, we won't get an authentication because our database has changed. And over here we can see that we have the same keys in our database. So let's just set another new key. And okay, so now our set and get is successful.